Alrighty, today's lesson is going to be all about transformations, and this works for a number of different functions, but we're going to focus on absolute value functions because it's pretty easy to see these shifts. So a parent function first is just the simplest form of a function. So y equals x, that's a really simple form of a linear function. Y equals x squared, that's a really simple form of a quadratic. Today we're going to work with absolute value functions, as I mentioned. So transformations can be performed and include shifts. We move things right or left, we move things up or down, stretches or shrinks, where they narrow or widen the function's graph, and then also reflections, where we can flip it. So Desmos.com, by the way, awesome tool anytime you're working with graphs. You can go plug them in, graph things if you have questions. But I really don't think we need that today with what we're going to be doing. But again, I just want you to keep that in your back pocket. Desmos, awesome tool. Okay, so here's this basic function below. That's what absolute value of x looks like. So just kind of keep that in mind as we work with some things today. Now here, I would encourage you maybe to pause and write these things down. Okay, it's really going to help you as you go through the lesson today. So I'm presenting it a little bit differently than they are, but the general form can be written like this. So y equals a, so that's some coefficient, absolute value x minus h plus k. Now what do all these letters stand for? What do they represent? hk is the vertex of the graph, so it's that point. Okay. H causes horizontal shifts, so inside there with the x, that causes right or left shifts, and the sign to that one feels backwards. We'll talk more about that. K, the number that's added or subtracted outside, causes vertical shifts, so up and down, and those match the sign that you see in the equation. Now if a is negative, so if you have a negative coefficient out front, it's going to flip your graph. We call that a reflection in the x-axis. And if the absolute value of a is greater than 1, basically if this coefficient is bigger than 1, then that's a stretch. It's going to make your graph more narrow, more steep. Okay? And if a is in between 0 and 1, so it's like 1/3, 1/5, 1/2, something like that, then it becomes wider. It takes that V shape and it widens it out. We call that a vertical shrink. So those again are the basic characteristics. Again, I'd encourage you to write these down if you haven't already. Let's go look at some examples. So here's a basic type problem. So for y equals absolute value of x plus 2.5, graph the function. Well, what's going to happen? We just talked about it. That's outside, so that's a k value. Can you remember what that does? It's going to shift it vertically, and in this case it's going to go up because it's a positive value. So let's look at these. Can't be that one. That shifted left. That shifted down. Hey, that shifted up. That's our winner. That one shifted right. See kind of what we're doing there? Now I got 4 problems on this one. Let's run through these. So describe the translation, combine things. So inside now, okay, here's that horizontal. Remember, it's inside, and this is where the sign feels backwards. I see the positive sign, but this is actually going to be shifted left 1/2. The reason for that is I plugged in a negative 1/2 there. That's why the sign's positive, because it was x minus h in the original equation. And this one's going to go down 4.5. Okay, that sign matches. So let's see which one says that. So 4.5 right, nope. Nope. 4.5 left, nope. Half left, 4.5 down. So D would be the correct answer there. Okay. How about this guy? So got that 5 inside. Notice the negative, but it's going to fill backwards. So it's actually going to go right 5 and up 3. So 5 right, 3 up. Looks like right off the bat we found our correct answer there. Now how about these? What if they want us to write the equation that would give us this? So I want you to focus on this point right here, the vertex. Okay? Notice it was here. It shifted over 4 and down 2. Over 4 and down 2. So what would that look like? Well, y equals absolute value of x. Let's see, it went right 4, so it's going to be x minus 4. Remember, that's the one that fills backwards. And then minus 2. it was shifted down 2. Now on these ones where I'm giving them to you, I'm not going to worry about any numbers in front. They're just going to be the basic. They're not going to be wider or more narrow. Okay, you'll see a little bit of that in the lesson, but I'm not too stressed about it right now. How about this one? Can you tell what it did? So it went left 4 and up 2, didn't it? So left 4, so that's going to be x plus 4. Again, that's the one that fills backwards. So plus 4, and then plus 2 shifted it up as well. Okay, one more. Describe the graph. Just in very basic terms, what did all these things do to it? Well, there's a negative out front. So it's reflected in the x-axis. Okay, it's flipped upside down is how you'd recognize that. Hey, there's a 1/2 right here. So that's a vertical shrink, or you could say it shrunk by a factor of 1/2 if you want. This one we should be familiar with, just talked about some examples like this. So that's going to be left 2 units. Remember that sign fills backwards. And up 4 units. So a lot of changes. That all comes from this basic graph. But look at all the things we can do to it to create an infinite number of functions. Alright? So I hope that'll help get you started and help you get through this lesson.